Hello everyone, my name is Nikita and I'm from the Bodhi Academy. In the last video, we had discussed some concepts of the chapter Gravitation from 9th Standard Science textbook and we had studied what is buoyancy. Today we are going to deal with the last part of the chapter and we will see what are the concepts in this chapter. Okay. When we were talking about buoyancy, we had studied what is buoyancy. So what is buoyancy? We had understood that buoyancy is nothing but it is the upward thrust, okay, and which an object experiences when placed in water. Of the fluids, okay, that is meant by buoyancy. Now there are two concepts with regards to this buoyancy. One is when an particular object sinks in the water, and one is when a particular object floats inside the water. For example, the nail, okay, nail when placed inside the water, an iron nail, will it sink or float in the water? Okay, the nail will sink in the water, okay. Whereas if I put a small cork, okay, then bottle cork, then what will happen to it? It will float on water, okay. Now why does this happen? This is because the force due to gravitational force of the earth on the iron nail pulls it downwards. Okay, so now we know that whenever we place an object inside the water, first of all there is always a gravitational force which pulls the object downwards, okay, which pulls the objects downwards, right? But now there is also the upthrust, which pushes it upwards, okay. But why does the iron nail sink then? Why is this upthrust not acting? Why is the iron nail sinking? This is because the downward force, first reason is downward force is greater than upthrust. Okay. And second reason is that the density of the iron nail is more than the density of water. Of water, okay. This is the first concept, why the object iron nail it sinks inside the water, okay. Now second is the cork floats while the iron nail sinks. This happens because of the difference in their densities. Now we talk about the cork, okay. First of all, the cork is lighter, okay, and it has a lesser density than water. So what happens? It experiences a upthrust by the water, which is greater than its density. So the cork floats on water. So the main question over here will be, explain why an iron nail sinks inside the water and a cork floats on water. Okay, so we have to say that First of all, the iron nail experiences a downward force, gravitational force, which pulls it downwards. There is upthrust which pushes it upwards, but because the downward force is greater than the upthrust and density of iron nail is greater than density of water, it sinks. Okay. And secondly, why does cork float on water? This is because cork is lighter, the density of cork is less than the density of water, and the upthrust by which the cork by which the upthrust experienced by the cork of the water is greater than its density, which makes it to float on water. So this is the concept of floating and sinking. Now the last part is the Archimedes principle. For this we need to do an experiment. Okay, take a piece of stone and tie it to the end of a rubber string or a spring balance. Okay, so you have to take a stone and tie it to a string or a spring balance. Suspend the stone by holding the balance or the string. So you have to hold it in this way and let it suspend. Now slowly now note the elongation of the string or the reading on the spring balance due to the weight of the stone. So you have to see how much the string is elongating itself, or if the spring balance is there, you have to note a reading on the spring balance. Now this is the first case. In the second case, you have to slowly dip the stone in the water in a container. You have to see in the container and you have to check the extension, if the extension is the same in both the cases. You will find that the elongation of the string or the reading of the balance decreases as the stone is gradually lowered in the water. So in the first place, we will see a larger extension. Okay, we will see a larger elongation. We will see a larger elongation, and in the second case, we will see a smaller elongation. Okay, once you put it in water. Okay, however, no further change is observed once a stone is fully immersed in the water. Okay, we know that the elongation produced in the string or the spring balance is due to the weight of the stone in the first case. Since the extension decreases once the stone is lowered in the water, it means that some force acts on the stone in the upward direction. First of all, we know that why is the extension? Because of the weight of the stone. But in the second case, the extension is lowering. Why is it so? Okay, this is because the stone is experiencing some upward force. Okay, some upward thrust, which makes it to, which pushes it upwards, and the extension hence decreases. Okay, so since the extension decreases once the stone, as a result, the net force on the string decreases, and hence elongation also decreases. Okay, so elongation also decreases. We already know that this is buoyancy. Now, does this mean that every object which is immersed inside the water, it experiences the buoyancy? Okay, what is the magnitude of the buoyant force experienced by a body? Is it the same in all the fluids for a given body? Do all the bodies in a given fluid experiences the same buoyant force? Means we know that objects which are immersed in the water are experiencing a buoyant force. Now our next question is, do all the objects experience the same buoyant force? Okay, and is it the same for all the fluids? Okay, and do all the bodies in a given fluid experiences the same buoyant force? This question is answered by Archimedes. Okay, he gave the Archimedes principle, wherein he said that when a body is fully or partially immersed in a fluid, it experiences an upward force. Okay, it experiences an upward force that is equal to the weight of the fluid displaced by it. Okay, so first part of the question is, of the principle is, when the body is fully or partially immersed in the fluid. Okay, second is, it experiences an upward force. Okay, third one is, this force is equal to the weight of the fluid displaced by it. Okay, if suppose this is the fluid, okay, and you are displacing an object in this, okay, this has a weight W. Okay, so weight W, so this object will experience an upward force equal to the weight, how much it has displaced the fluid. Okay, so this is the Archimedes principle. This is the reason why the ships, they can easily, the ships being, you know, larger in size, they do not sink inside the water but they float on water. This is because they are experiencing an upward force which is equal to the weight of the fluid. If it was not equal to the weight of the fluid, then it would have sunk. Okay, Archimedes principle has many applications. It is used in designing ships and submarines. Okay, then these applications are important. Second is lactometers, which are used to determine the purity of a sample of milk, and hydrometers for determining the density of liquids are based on this principle. Okay, so Archimedes principle application is designing of ships and submarines, lactometers and hydrometers. So this was about Archimedes principle. So we have completed the chapter. Today we saw what is the concept of buoyancy in the sinking and the floating. Then we saw the spring balance experiment. Okay, and then we saw the Archimedes principle and the application of Archimedes principle. So this was the chapter Gravitation from 9th standard science textbook. So yes, thank you for watching my video. Please like, share and subscribe to our channel.